Okay, so in this video, basically what we are going to be discussing are quadratic equations and basically just how to plot them, okay, how to sketch them even. All right, so when we are talking about quadratic equations, or let me better say equations generally, equations can be in many different categories. Equations can be in many different types, okay. Like a good example, when we're talking about equations, they're in various many types. Like a good example, number one, we have something which we call linear equations. Linear equations. Linear equations are equations which are in the form y is equal to mx plus c. Okay? Linear equations are equations which are in the form y is equal to mx plus c, where m is termed as the gradient and c is going to be termed as the y-intercept. The y-intercept, and one thing that we need to know is that this is a constant. It can be any number, positive or negative, inclusive of 0. Secondly, we have what we call quadratic equations, and this is what I want to talk about much. How to plot them, how to sketch them, and everything. Quadratic equations. Quadratic equations are equations which are in the form y is equal to ax squared plus bx plus c. Okay, these are equations which are in the form y is equal to ax squared plus bx plus c, where a, b, and c are constants. But like I had labeled here, c is always the y-intercept. Even here, this c is going to be the y-intercept. You're going to notice that when we're talking about linear equations, they are just so direct in determining their gradient. You just have to look at that coefficient which is moving with the x variable. But when we're talking about quadratic equations here, we cannot just determine the gradient directly just by looking at the equation. There are many ways in which we can determine the gradient of a quadratic equation, but basically we can do that by a method known as differentiation under the calculus, provided that a point has been given. Okay, so let's get in depth about these quadratic equations. How can we plot them? How can we sketch them? Okay, so here we go. Let us try to analyze this thing first. We said that quadratic equations are always in this form, y is equal to ax squared plus bx plus c. When sketched, quadratic equations can come out in this way, or they can come out in that way. This is their nature. If it comes out in this way, we tend to say that it has a maximal nature. Maximum nature. If it comes out in that way, we tend to say that it has a minimum nature. Minimum nature. Now, what is going to be determining the nature of the quadratic equation when sketched or when being plotted? Well, your eye should be on the value of a. If a in a given quadratic equation is negative, that is, if it's less than 0, if it is negative, then your graph is going to have a maximum nature. But if a is greater than 0, that is, if it is positive, because of course it is only values that are greater than 0 that are positive. So if a is greater than 0, then your graph is going to have a minimum nature. So we have a maximum nature and we also have a minimum nature in this way. So let us look at some few examples and then we see where we're going to go. Let us imagine maybe this is our first example. You have been given this equation, y is equal to x minus 1 and then x plus 2 here. So take note, quadratic equations cannot be just given directly in this form, y is equal to ax squared plus bx plus c. That is, as an example, maybe say y is equal to 3x squared minus 2x plus 5. Yeah, they cannot just be given directly to you like that. At times they can tend to play around with things where this time it can be represented or given in this format. So we want to sketch y is equal to x minus 1, x plus 2 here. So what can we do? What steps can we make? Well, it's very much important that you first determine something which I like to call your intercepts. Your intercepts. You need to know exactly where it is passing through the x-axis and also where it is passing through the y-axis, because if we don't know exactly where it is passing through the x-axis or the y-axis, you're going to find out that it's going to be hard for you to just like sketch it up like that. So you need to know the intercepts. Alright? Now, even before you go to the intercepts, you can first determine its nature. You're going to see that the value of x here, or let me not say the value of x, but if you look at the x here, the x is somewhat positive. This one is also positive. If we expand it, it's going to take up this form. So if we expand it, you're going to see that this is going to be like x times x, which is basically going to be x squared. And the coefficient of x squared right there is 1, and the 1 is a positive. So even before plotting it, you can be able to determine exactly how it's just going to be. It's like you're going to have an idea, like, okay, this is how it's going to come out. So if you notice, this is just like x times x, which is basically going to be like x squared. A positive one to be specific. Hence, that graph, even when you begin to sketch it, it's going to have a minimum nature. Alright? So, like I said, it's very much important that you determine your intercepts. Let's start with our x-intercept. When determining our x-intercept, you need to put into consideration that your y value should always be equated to 0. So, in this equation, y is equal to x minus 1, x plus 2. On y, you're just going to put 0. And this is going to be x minus 1, x plus 2. If we equate these things individually to 0, what we're going to have, so this should be equated individually to 0. Even this guy here, to 0 individually. So we're going to have x minus 1 is equal to 0. And we're also going to have x plus 2 is equal to 0. So x will be equal to 1. X will be equal to negative 2. That is, if you properly apply your arithmetics there. So x will be equal to 1 and x will be equal to negative 2. And that's it. You have determined your x-intercepts. What about our y-intercept? How can we handle this problem? How can we determine our y-intercept? Well, it's just the opposite thing. When you were determining your x-intercept, we had let y to be equal to 0. Here, when you're determining your y-intercept, we tend to equate our x variable to 0 in this problem. Okay, so when you're determining your x-intercept, your y is equal to 0. When you're determining your y-intercept, your x value is going to be equal to 0. Alright, so basically when we say x-intercept, we just want to know exactly where the quadratic equation is passing through the x-axis. When we talk about the y-intercept, we just want to know exactly where that equation is passing through the y-axis. And by the way, your x-intercepts can also be termed as your roots. Okay, your x-intercepts can also be termed as your roots. Now, under ordinary mathematics, they don't normally mention much about it. But when we begin to do things like advanced mathematics or additional mathematics, this is where we tend to get in depth even on how to describe the type of roots that are there. So for now, just know that your x values that you determine, your x-intercepts, can also be termed as the roots of the quadratic equation. Okay, so our y-intercept is basically x is equal to 0. That's the concepts that we apply. So again, you make reference to your original equation, x minus 1, x plus 2. Your x value is becoming 0, so y will be equal to 0 minus 1, 0 plus 2. Y will be equal to 0 minus 1, that's negative 1, 0 plus 2, that's just going to be positive 2, right? Well, there is a multiplication taking place here. Negative 1 by positive 2, the answer is just going to be negative 2. And that's it. You have determined your y-intercept. You have determined your x-intercepts, your roots. You have also determined your y-intercept. Now, doing this alone is not enough. At least you need to know the turning point as well. Notice that in these simple sketches which I have made for you here, you're going to see that it's just not rising infinitely or dropping infinitely. You're going to see that there is always a certain point where it is going to turn. Okay, there will be certain points at which these two sketches are going to turn, and just by these statements, these points at which these graphs are turning on, these are going to be referred to as your turning points. These are going to be referred to as your turning points. You can also call them stationary points. Stationary points. Why stationary points? That's the question. Why stationary? The reason why I tend to call them as stationary points is because at this point, your dy dx, of course when you're talking about the calculus, your dy dx is always going to be equal to 0. Hence, this is the reason why these turning points might also be termed as stationary points. Why? Because it is at these points where your dy dx is equal to 0. Alright, equal to 0. So you need to know exactly where it is turning. If you don't, that can be very troublesome, burdensome even. So let's see how we can determine now the stationary points of these quadratic equations, especially when you're sketching them. Okay, especially when you're sketching them.